Hello, my darlings. Okay, we're back to do some more U substitutions. All right, so we know that the derivative of e to the u is e to the u times the derivative of u, right? That means that the antiderivative of e to the u times du is e to the u plus c. Now, the problem is when there's a function up there in the exponent, that's the inside. So, for instance, this e to the 5x, that 5x is inside e to the x, and that's our u. So we let u be the 5 to the x, and now we take the derivative. The derivative of u is du dx, and the derivative of 5x is 5. If we multiply both sides by dx, and then divide both sides by 5, we have du over 5 equals dx. Now we can make the substitution. We have the integral of e to the, instead of 5x, we're going to call it u, and instead of dx, we're putting in du over 5. Now remember that over 5 is a constant, so it's 1/5 times the integral of e to the u du. We keep the constant 1/5, and what has a derivative of e to the u? That's e to the u plus c. Last step, we change back. We have to substitute back into terms of x's. So we have 1/5 e raised to, the u is 5x plus c. There we go. Integral done. Now, remember when we talked about taking the antiderivative of u raised to a power, and it's just u raised to add 1 to the exponent and divide by the new exponent. But we said that didn't work when n was -1, because when we added 1 to -1, we got 0, and we can't divide by 0. That's because u to the -1 is 1 over u, okay? And what has a derivative for 1 over u? That's the natural log of u. Now, there's one thing you have to be careful about. When we go backwards and do the antiderivative of 1 over u du, we don't just say it's the natural log of u plus c, because we have to be careful. We know for the natural log of x, you can only have values of x that are greater than 0. The domain of a natural log is x greater than 0. So what we do, the antiderivative of 1 over u du is the natural log of the absolute value of u plus c, okay? So if we look at this example, 8 dx over 2x plus 3. Our denominator is 2x plus 3, so that's our u. When we take the derivative of u is du dx. The derivative of 2x plus 3 is 2. So I'm going to multiply both sides by dx, and then I'm going to divide by 2, so du over 2 equals dx. So now we're going to make the substitutions. I have the integral of 8 over our 2x plus 3 is u times our dx is du over 2. Now we can simplify this 8 and this 2. 2 goes into 8 4 times. And 4 is a constant, so that can factor outside of our integral. So we have 4 times the integral, and what's left is 1 over u du. So that's 4 times the antiderivative of 1 over u is the natural log of the absolute value of u plus c. So this is 4 times the natural log of the absolute value, but my u is 2x plus 3 plus c. And there's the answer to that integral we have evaluated. Let's try another one. Oh, this one looks scary. The integral of e to the x over 1 plus e to the x. Oh my goodness, what's our u going to be? Well, remember, we said when we're not sure, do we have anything messy raised to an exponent? No, I don't. Do I have a denominator? Yes, I do. So we're going to let u be that 1 plus e to the x. Now, if we take the derivative of u, du dx, the derivative of 1 is 0, and the derivative of e to the x is e to the x. So we're going to solve for dx. We multiply both sides by dx. Then we have to divide by e to the x, so du over e to the x is dx. So now we're going to substitute. We have the integral of e to the x, I don't know what I'm going to do with that yet, over, wait a minute, 1 plus e to the x, that's my u, times my dx is du over e to the x, and lo and behold, this e to the x is going to cancel out with that e to the x, and all I have is the integral of 1 over u du, and that's easy. What has a derivative of 1 over u? Well, that's the natural log of the absolute value of u plus c, or the natural log of the absolute value. What was my u? 1 plus e to the x. Now, just a thought here. You know e to the x looks like this, right? E to the x is always positive, true? And 1 is a positive number. So if I take 1 and I add a positive number, that's always positive. So technically, we don't need an absolute value on this one because the domain would be satisfied without it because 1 plus e to the x is always positive. So it's possible on a multiple choice question that that answer may not have the absolute value. So watch out for that. Okay, now you didn't like these as derivatives, so we're going to go through this again for antiderivatives. If u is any differentiable function of x, then the integral of a to the u du, so that's something like 2 to the x, 3 to the 5x squared plus 2x minus 1 dx, okay? Those are things that we're talking about. Well, this integral of a to the u du is the same a to the u divided by the natural log of the base a plus c. So we're going to prove this, all right? We're going to prove this first because it might help us remember the derivative rules. So we know that the derivative with respect to x of a to the x is a to the x times the natural log of a. Do you remember that derivative? If not, it's time to get that back in your head. I'm going to multiply both sides by the dx. Okay, and then what I want to do is I want to integrate both sides, right? I'm allowed to do anything to but one side if I do it to the other side. Now here's the thing. What do we know about integrals and derivatives? They're inverses, they undo each other, so all I have on the left side is a to the x. Also, natural log of a is a constant because the derivative here is with respect to x, so the natural log of a is a constant, it can factor right back out. And I still have the integral of a to the x dx. Now I can divide both sides by that constant. A to the x divided by the natural log of a is the integral from a to the x dx. Ta-da! And there we go. You proved it. Now let's try to use it. All right, we proved it. Now let's use it. So now this time, we're going to let, instead of something raised to an exponent, since the x is in the exponent, we're going to let the exponent be the u. So sine x is the u, okay? And the derivative of u is du dx. What's the derivative of sine? That's cosine x. Notice its derivative is sitting right there. Okay, so we need to solve for dx. So we're going to multiply both sides by dx. And then divide, so du over cosine x equals dx. So now we're going to substitute. We have the integral of 2 raised to, instead of the sine x, we're going to put a u. And we still have times cosine x times dx, though, is du over cosine x. And what happens here? This cosine x and this cosine x cancel out. We have the integral of 2 to the u du. So according to our model, that's 2 to the u divided by the natural log of the base 2 plus c. One last step. We got to change that u back to the sine of x. All over the natural log of 2 plus c. All right, guys, so we have reviewed integrals of e to the exponent, the integral of 1 over u, which is the natural log of an absolute value, and the integral of a number raised to a function of x. So 3 more types of u substitution problems. I will see you in class and we'll be doing more of these. Have a great day.